Good morning everyone. Welcome to today's GATE video. Today we are going to discuss about the topic on data structures, and also we are going to discuss about some of the GATE questions related to the subject data structures. We will be studying about the non-linear data structures. I am S.A.E.C, Assistant Professor of Computer Science and Engineering Department of S.A.E.C Engineering College. Let us go into the questions. So this is the outline of what we are going to discuss today. So we'll be discussing about the data structure, the term tree, what is called binary tree, then the binary search tree, then B tree and B plus tree, and then we'll be studying about some of the GATE problems related to these trees. So first, what is a data structure? So data structure, it is nothing but it is a way of organizing the data in our computer. So consider we are having some 100 elements. If you are going to arrange these elements in a pattern, it will look like, and so that the searching and sorting the elements will be easier for us. So this data structure is nothing but it is a way of organizing and storing the data in the computer so that it can be accessed and used efficiently. So some examples of the data structures includes array, stacks, queues, trees and graphs. So the next is classification of the data structures. The data structures can be classified into two types as linear data structure and non-linear data structure. So from the term linear data structure, it means here the data elements will be arranged sequentially and in a linear pattern. For example, we can take arrays and stack. So this array, stack and queue all. So how is an array look like? So it consists of a sequence of elements arranged in the next memory location. So in the case of stack, it is a structure of a stack. So the elements will be arranged sequentially. Then how the queue will look like? So this is the structure of a queue. So the elements will be arranged in a pattern. So this end is open and this end is also open. So the elements can be arranged. So this is an example for the linear data structure. So here the elements will be arranged in a linear pattern. The next is a non-linear data structure. So from the name itself, non-linear data structure means where the data elements are not placed sequentially. The elements will be placed randomly. So the example includes trees and graphs. So trees and graphs. So what is the structure of a tree? So we'll be having the elements like root node followed by the child node. So how the graph will look like? It also consists of the nodes collected by vertices connected by means of the edges. So this is an example for a graph. So these are the classification of the data structures. So next part is the detailed classification. So data structure is divided into two types as a linear data structure and non-linear data structure. So linear data structure consists of a static data structure and dynamic data structure. Here the static data structure includes arrays and the dynamic data structure includes queues, stack and the linked list. Then the non-linear data structure classified again into the trees and the graphs. So this is the overall classification of the different data structures. Next, we are going to study about some of the applications of the data structures. So when we track the applications, we have the databases, operating systems, computer graphics and the artificial intelligence. So in the case of data structures, it is used to organize and store the data in the database. So in the case of operating systems, it is used for the design and implementation of the OS, for efficiently managing the resources. In the case of computer graphics, it is used to represent the different geometrical shapes and also for the storing of the data. In the case of artificial intelligence, it is used for the data storage and also to represent the knowledge and the information. So these are some of the applications of the data structures in the different fields. The next is we will be studying some of the advantages of the data structures. So when using some of the data structures, your data can be arranged efficiently, and if you want to search a particular element of an array, if it is arranged in a particular pattern, the data can be picked efficiently. The second one is flexibility. So it is used to use a flexible way to store our data and also to retrieve the data from the data structure. And the reusability, so that a particular data structure can be reused again and again. The next is maintainability. So it can be easier to store a large amount of the data. So the advantages of data structures includes efficiency, flexibility, reusability and maintainability. The next is we are going to study into the non-linear data structure. So as we saw the classification, the data structures includes two. One is a linear data structure and another is a non-linear data structure. In the non-linear data structure, the basic things are the trees, the graphs and the queues. So first we will be studying about the tree data structure. The tree data structure is nothing but it is a non-linear data structure in which it consists of a collection of elements known as the nodes which are connected to each other through the edges. So here is an example of a tree. So here in this tree, these are called as the nodes. The first topmost node is called as a root node and other nodes are called as the children of this root node. So again this tree is called as a subtree. In the subtree, this node is called as a parent node and this is called as a child node, and the nodes at the lowest level are called as the leaf nodes, and the nodes at the same level of the same parent are called, the children of the same parent are called as a sibling. So this is an example of a tree data structures, how a tree will looks like. The next is a binary tree. The binary tree is one of a type of a tree. So it is nothing but it is again a non-linear data structure. So here the condition is that each node consists of at most of 2 children. So at most of 2 children means you have 0 children or 1 child, or you can have 2 children. So at most of 2 children will be there. So here we can take this example. So here the node with the element 15 is called as a root element. So it consists of at most of 2 children. So the left child is 35 and the right child is having the key value as 40. Again this left child is having 2 children but data value is 3 and 6. So here the first node, the root node will be at the level 0, the next will be at the level 1, the next stage will be level 2 and the level 3. So each will be connected. So here these are called as the nodes and these are connected through these lines which are called as the edges. The nodes at the lowest most level are called as the leaf node and the topmost node is called as the root node. So next is a binary search tree. This is also one type of a tree. Again the binary search tree is a binary tree. So what is a binary tree? It can have at most of 2 children. The next condition for the binary search tree is that here you will be having a root element. The condition is that the element in the left subtree must have the key values which should be lesser than the root node, and the elements on the right subtree should have the key values which are all greater than the root element. So the left elements will be lesser than the root node and the right elements will always be greater than that of the root node. This is a condition for a binary search tree. So when we starting with the 0 node, while inserting each and every element, you have to check the condition. First you will be inserting the first node which will form the root node. After inserting the next node, you have to check whether it is lesser than the root node. If it is lesser than the root node, you have to insert at the left subtree. If it is greater than the root node, you have to insert at the right subtree. This is a condition, basic condition for a binary search tree. So it's an example for a binary search tree. So here you see it is a binary tree, that is at all the nodes it will be having at most of 2 children. So here the topmost, the root node is having the value 11. So the next key value is 2 which is lesser than the 11. So it is inserted at the left subtree. The next value is 29 which is greater than 11. So it is inserted at the right subtree. So you can see all the elements at the left subtree are lesser than the root node and all the elements in the right subtree are greater than the root node. This is a condition for a binary subtree. Binary search tree. The next is the B tree. This is the next level of a binary tree. So in the case of a B tree, it allows for a M-based search. That is, as we have seen in the binary tree and the binary search tree, each node will be having only one key value. So this B tree allows you to have more than one key value. So based upon the order M, so the B tree will be having some order M. So based upon the order M can have n number of elements inserted. So here we will be having m children and m minus 1 key values allowed for each node. So if the order is given as m means you can have m children for that particular node, and also the node will be having m minus 1 key values. This is the condition for a B tree. The usage of this B tree is that you can have more number of elements stored, and also the storage has become efficient one. So this is the use of this. So here a significant number of the keys within a single node can be added, which is an advantage of using it than that of the binary tree. So here it is used for a faster data retrieval, and also you can make the updates easier as n number of keys are available in a single node itself. So the storage has become in an efficient way. So this is an example for a B tree. So consider here the root node consists of element 100. So the left subtree consists of a single node which has two key values. The key value is 35 and 65, which is lesser than this 100. And the right side consists of a single node with two key values. So these two values 130 and 180 are greater than this node 100. Then the left node consists of three children. So those nodes will be having value lesser than this node, and the right side will be greater. So this is how a B tree will look like. So next is a B plus tree. This is next to that of a B tree. This advanced version of a B tree. So it is also M-way search tree. The condition is the difference between the B tree and the B plus tree is that in the case of B tree, we'll be having only the key values. But in the case of B plus tree, in order to improve the efficiency, you will be having the index values. So here the key values are stored only in the leaf node, and the key values, all the actual data will be stored in the leaf nodes, but the internal nodes will be containing the index values. So the index for the key will be provided in the internal node. So for example, if you take a book, when you want to find out a particular data, what is the use of the index? So the index will have all the page number so that it will be easy for us to locate the data. So similar to that, the data value present will be in the leaf node. For locating a particular data, you can use the internal node which acts as an index to locate that particular data. This is what is called as a B plus tree. So this is an example for a B plus tree. So here you'll be based upon the order M, you'll be having n minus 1 keys and M node children. So here, for example, here we have a data value 3. For this data value, the index is stored in the internal node. These nodes at the lowermost level are called as the leaf node, and the nodes at the previous level are called as the internal nodes. The internal nodes will be having the index, and the leaf node will be having the key values. So now we have seen about some introduction about the non-linear data structure, that is a trees. We have studied about what is called a tree, what is a binary tree, what is a binary search tree, then B tree and B plus tree. Now we are going to solve some of the gate questions that were asked in the previous year. The first question is that it was taken from the year 2025 set 2. So first question is, suppose the values 10, minus 4, 15, 30, 25, 60 and 19 are inserted in that order into an initially empty binary search tree. Let T be the resulting binary search tree. The number of edges in the path from the node containing 19 to the root node of it. So first, whenever a question is given, you need to find out some of the important data. So what is the first important data here? You are going to construct what type of tree you need to construct? You are going to construct a binary search tree. So you are going to construct a binary search tree, that is the first point. The second point is you have to check about the key values. You are given that you are going to insert the key values in the order into an empty binary search tree. So the tree is initially empty. You are going to insert the values in the given order. So first, what is the first value? Now we are going to construct the binary search tree. So how the tree will be? Initially it will be empty. Now the first value, what is the first value? 10. So insert a first node with the key value 10. So we are done with the first value. What is the next value? It is minus 4. Now you check where to insert the value. So what is the condition of a binary search tree? You have to check the element with the root node. If it is lesser than the root node, you have to insert at the left side, or if it is greater than the root node, you have to insert at the right side. So now minus 4, it is lesser than 10. So I am going to insert in the left subtree. So it is the first left child of the root node. The next value is 15. So compare it with the root node again. So 15 is greater than 10. So I insert it at the right subtree. So I have inserted. Now the binary tree is completed at the level. Now the next element is 30. So where you have to insert 30? So compare with the root element. Here it 30 is greater than 10. So go to the right. You have 15. Again 30 is greater than 15. So it must be inserted on the right. So it becomes the right child of the node 15. Okay. Now what's the next element? 20. So again compare it with the root node. 20 is greater than 10. So come to the right. So again 15. 20 is greater than 15. So go to the right. Now compare it with 30. 20 is less than 30. The condition is 20 is less than 30. So where will you insert? You should insert into the left child of the 30. So we are done with 20. Now the next value is 5. So how to insert 5? So compare it with the root element. You have 10. So 5 is less than 10. So you have to go to the left subtree. Now here you have minus 4. So 5 is greater than minus 4. So I have to insert in the right child. Okay, now the next value is 60. So where will you insert 60? So 60 is greater than 10. So you have to go to the right subtree. Again 15. So 60 is greater than 15. So go to the right. So you have 30. So 60 is again greater than 30. So I can insert here. So that becomes the right child of this subtree. Now the last value is 19. So where to insert 19? So compare it with 10. 19 is greater than 10. So go to the right subtree. 15. It is greater than 15. So go to the right subtree. 30 is. Now the question is, if you are going to insert the node 19, so what is the number of edges in the path from the node 19 to the root node? This is a question asked. So this is the completely formed, right? So now you check the number of nodes in the tree. So from the edges, number of edges. So starting from the node 19. So what is the first edge? This is the first edge. So this is second edge. This is the third level, and this is the fourth level. So starting from the node 19, so how many edges are formed? So 4 edges are there. So the answer for this question is 4. So what is the question? The number of edges in the path from the node containing the element 19 to the root node. So the node 19 is present here. So from there 1, 2, 3, 4. So the number of levels present is 4. The answer is 4. Now we will move on to the next question. So the next question is also a question related to the binary search tree. It is taken from the year 2015. So the question, let us go into the question. The question is, while inserting the elements 71, 65, 84, 69, 67, 83 in an empty binary search tree, the element in the lowest level is. So you are given with some set of elements. You are going to insert these elements into a binary search tree. Now the question is, what is the element in the lowermost level? Now let us construct the binary search tree first. So the given elements are 71, which is made as the root node. Now what is the next element? 65. So where it will come? So 65 is lesser than 71. So it will be inserted at the left subtree. What is the next value? 84. So compare 84 with the root node 71. So 84 is greater. So it will be inserted at the right subtree. 84, right? Now what's the next value you have? 69. So where to insert 69? So compare it with 71. So 69 is lesser than that. So now compare with 65. 69 is greater than 65. So you can insert at the right side. Now 71 completed, 65 completed, 84 completed, 69 completed. What's the next node you have? 67. So where to insert 67? So compare with the root node. 67 is lesser than 71. So come to the left subtree. Again it is greater than 65. So go to the right subtree. When you compare with the right subtree of 69, 67 is less than 69, right? So where to insert? It is inserted as the left child of this node. Okay, now what is the next node? 67 completed, so 83. So where to insert 83? So 71, 83 is greater than 71, so go to the right subtree. So you have 84, but 83 is less than 84. So we'll be inserting here. So this is how the binary search tree is formed. Now you see this tree. So this is level 0, this is level 1, level 2, and this is level 3. Now what is the lowermost level? This node. This is the leaf node, the lowermost node. So now what is the value present in the lowest level? It is 67. So your answer is B. So the solution for this is how you can derive the solution for the given question. So this is the structure formed, how the tree is formed, and the different levels, and what is the node at the lowermost level. The next question is, it is taken from the GATE year 2017. This is a question again related to a binary search tree. So here the question is, let T be a binary search tree with 15 nodes. So what is the number of nodes given? You are given with 15 nodes. So n is equal to 15. The number of nodes is 15. The minimum and the maximum possible height of the tree. You are going to find out the minimum height and the maximum height of the tree. Okay, understood? So here a note is given. It is that the height of the tree with a single node is 0. That is, if you are having only one node in the tree means the height will be 0. If you are inserted with the other nodes means the height will be 1. So this is how it is be going. So you are given with 15 nodes. You are going to find out what is the minimum height and the maximum height of the tree. Okay, so now how you can form the tree in this? So the given options are, so you have 4 options. The first one is the minimum value is 4 and the maximum value is 15. The second option is the minimum height is 3 and the maximum height is 14. The next option is with minimum height 4 and maximum height 14. Last option is with minimum height 3 and maximum height 15. Now you are going to find out from these options which one will be the correct. Now tell me how a binary search tree will be formed. So consider here we have 15 nodes, right? So how will you construct a tree with 15 nodes? So we can make it in 2 ways to find out the minimum and the maximum. So first we will find out the minimum height of a tree. So if I have 15 nodes means how will you form a tree? So we will have a root node, then level 1 will be having 2 nodes, then level 2. So it will be having 2 nodes, it will be having 2 nodes, right? How many nodes are here? 1, 2, 3, 4, 5, 6, 7 nodes are here. So totally we will be having n is equal to 15. So we have given 7 nodes. Now this will be having 2 child, one left and right. So this will be having 2 child as one left and right. This node will be having 2 children left and right. This node will be having 2 children as left and right. So this is how a binary search tree is formed, right? If you are given with 15 nodes. So now count the number of nodes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have constructed a tree. So it is a complete binary search tree because all the nodes will be having at most of 2 children. So we are given with the 15 nodes. Now check the height of the tree. So what is the height of the tree? So it is 1, 2 and 3. So what is the height of the tree? 1, 2 and 3. So the minimum height of the tree is 3. Okay, now we are going to find out what is the maximum height of the tree can be formed. So how will you form a maximum height of a tree? If you want to construct a tree with the maximum height, you have to construct it as a skew tree. The skew tree means the nodes will be aligned to either a left in a left skew tree or to a right on a right skew tree. So I will be having 15 nodes. So how will you construct a skew tree with 15 nodes? Now I am going to construct a right skew tree. So how will you form? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Now what is the height of the tree? So the number of edges will be the height of the tree. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So if you have 15 nodes, so the maximum height of the tree can be formed by using either a right skew tree or a left skew tree, which can be formed like this. So if you have a maximum of 15 nodes means the height of the tree would be 14. So now tell me the option which could be the correct one. So the option B, that is the minimum height of the tree is 3 if it is a balanced tree, and the maximum height would be 14 if it is formed as a skew tree. So this is the possible answer for this question. So this is the complete tree, and I have also explained you through the skewed tree. Now the next question is, so this question is taken from the year 2015. So the given question again it is related to trees only. The height of a tree is the length of the longest root to the leaf in the leaf path in it. So we have seen in the previous question, right? So how the height is calculated from the root to the lowermost level, it is calculated. It is given here. You should not confuse with the terms given. You read it once or twice so that you will come to the point. So the height of the tree is the length of the longest root to the leaf path in it. Now the question is the maximum and the minimum number of the nodes in the binary tree of height 5. So in the previous question, we are given with the number of nodes. We were asked to find out the height of the tree. In this question, we are given with the height of the tree, which is 5. We are going to find out the minimum and the maximum number of the nodes present in the tree. So in order to find this, we have a formula, right? So how to calculate the minimum and the maximum number of the nodes if the height of the tree is given. So here the height of the tree will be represented as h. So what is the height of the tree? It is 5. Now in order to find out the maximum number of the nodes in the tree, so here it is given that it is a binary tree. So what is the condition for a binary tree? Each node can have at most of 2 children. So in order to find out the maximum number of the nodes, the formula is 2 power h plus 1 minus 1. So to find out the maximum number of the nodes, so here h is 5. So 2 power 5 plus 1 minus 1, which is equal to 2 power 6 minus 1. So 2 power 6 is 64 minus 1 is equal to 63. So the answer for the maximum number of nodes present in the tree is 63. Now, if the tree is having the height is 5, means the minimum number of the nodes will be 5 plus 1, which is equal to 6. So in this particular tree, if it is a binary tree with the height as 5, means the maximum number of nodes is 63 and the minimum number of nodes present is 6. This is how you have to derive a solution for the problem. Now we have seen some of the questions related to the binary search tree. The next question is related to a B plus tree. So as I told you earlier, when you see the structure of the previous binary tree and the binary search tree, so here each node will be having many number of the keys. So the storage will be easier one. And also I told you that the leaf nodes will be having the key values and the inner nodes will be having the index value. So here if you take a particular key value, the leftmost nodes will be lesser than that and the rightmost nodes will be greater than the particular key value. So this is the given B plus tree. Now we'll get to the question. So here we are having 5 nodes. This B plus tree is having 5 nodes. So 1, 2, 3, 4 and 5 nodes are given, in which a node can store at most of 3 key values. So here the key value can be stored as 3. So let us see that each node is having at most of 3 key values. That is given here. Now the value of 23 is now inserted in the B plus tree. You are going to insert a particular value which is having a key value is 23. It is going to be inserted into the B plus tree. Which of the following options is correct? So the options are: none of the nodes will split. First option. Second option is at least one node will split and redistribute. The third option is the total number of the nodes will remain the same. There is no change will be there. And the last option is the height of the tree will increase. So these are the given options. From these options, you are going to check any one or two. Anything can be correct. You need to find it there. So how will you insert that? So here in the case of B plus tree, the number of key values will be present depends upon the order of the tree. So if it is given that the key value is going to be 3. So the number of key value is going to be 3. So the node can have at most of 3 key values. Now this is this is the structure of the tree. Now I want to insert the key value 23 into this tree. So when I want to insert the key value is 23, so where I can insert? Now the value is 23, so definitely it could be inserted here only. If I want to insert the value here, what is the condition here? A node can have at most of only 3 key values. Now if I insert this value into this position, this key will have 4 values. It's not possible. So what you should do? Definitely you are going to split the node and you are going to insert the value. So what will happen? The node will be split and the redistribution will happen. So what will happen? This node will be splitted into 2 parts, right? So it will be having 20 and 21 as one node, and another node will be having 22 and 23. This will happen. Now what will happen? We will take any one of the key value as the index value and it will go to the internal node. So now what will happen? This 22 will go up. So 6, 12, 19, this 22 will come here as an index value. Now what will happen again? This is 4 values, which is not possible. So you have to again split this. What will be splitted? So this is how it will happen. So right? This is how it will happen. So it is here, it is broken and it is redistributed. From that the key value will be taken into the top. So this is how it will happen. So this is explanation. And now what is from this given choices, what are the different answers possible? So first one is at least one node will split and redistributed. So the node is splitted, at least one node will split and it is redistributed. And one more option is also possible, the height of the tree will increase. So this option is also possible. Okay, the height of the tree is increased and the nodes are also distributed. Then first option is none of the nodes was split. No, this is not the case, the nodes are split. So second option, it is okay, at least one node got splitted. And the next one is the total number of the nodes will remain. No, the number of nodes are changed. So the from these given options, the possible solutions are, so the answers are B and D. So this is solution for this question. Okay, this is the last question. So it is taken from the year 2021. So let us read the question. Consider a complete binary tree with 7 nodes. So it is a complete binary tree with 7 nodes. Let A denote the set of first 3 elements obtained by performing breadth first search, starting from the root. So this is first. And B denote the set of first 3 elements obtained by performing depth first search, starting from the root node. So when we study the binary tree, we will be studying about the traversals, right? So traversal is nothing but visiting the different nodes of the tree from the root node. So now the given option, given values are, we are having 7 nodes in the binary tree. It is a binary, complete binary tree. So what is a complete binary tree? So complete binary tree is nothing but at different levels it will be having at most of only 2 children. At maximum child allowed is 2. So how many nodes are there? 7 nodes. So B, C, D, E, F and G. So this is an example we have taken. So if you are having 7 nodes means 1, 2, 3, 4, 5, 6, 7. This could be the structure of the complete binary tree. Now we are given with 2 things. One is let A denote the first set of 3 elements which are obtained by performing the breadth first search. And B includes the set of elements obtained by the depth first search of the given binary tree. Now we are going to first perform the breadth first search. So A is the breadth first search. So in breadth first search, how will you perform the search? Starting with the root node, you have to find out the adjacent elements of the root node. So A is the root node. So what are the adjacent elements? B and C. The first A will be visited, followed by the B, followed by the C. So breadth wise, level by level, the elements are found. So the breadth first search include the elements as A, B and C. Consider these are the elements obtained in the BFS. So BFS, the order is A, B and C. The next is you are going to find out the depth first search. So depth first search means you have to go by height. So height level you have to go. So what is the first element? B is the depth first search. The first element will be A to be visited. The second will be B to be visited. And the third will be D to be visited in the case of a depth first search. So the order is, in the case of DFS, the order is A, B and D. So now we have found out what is A and what is B, right? Now we are asked with what is the value of modulo A minus B. That's what's the difference between the values of A and B. So we have found out A as the set of values as A, B and C, and B performing DFS, this is BFS, and this is depth first search. The values are A, B and D. Now you need to find out A minus B, that are the values that are present in A but not in B. So A and B are common in both. The value of C is present in A, not in B. So the number of value is modulo, so the total value is 1. So the answer for this question is 1. So understood, the first elements obtained is A, B, C. The elements obtained by DFS is A, B and D. So the difference is only the value C, so which is value 1. So this is the final answer for this question. So we can continue in the next video. Thank you.